Ashish Kumar Pandey, and today I am presenting my project by sharing demand prediction, which is the supervised ML, come under regression. Team members are Ashish Kumar Pandey and Vivek Kumar Soni. The contents are individual information, business understanding, data summary, feature analysis, exploratory data analysis, data pre-processing, implementing algorithm, challenges, and conclusion. Basic understanding of business understanding. Bike rental have become very popular service in recent years, and it seems people are using it more often with relatively cheaper rate and easy of pickup and drop at own convenience is what making this business thrive. Mostly used by the people having no personal vehicle and also to avoid the conjugated public transport, which that's why they prefer rental bikes. Therefore the business to strive and profit more, it has to be always ready and supply number of bikes and different location to supply and demand. Our project goal is pre-planned the set of bike count variable, a handed solution to meet all demands. Data summary. This data set contain 8760 lines, which is row, and 14 columns. Three category features: session, building, and functioning. One time on date time feature data table. We have some numerical type variables such as temperature, visibility, dew point, temperature, solar radiation, rainfall, snowfall, environment condition at a particular hours of the day. The features: the date, time, year, rental, bike count of bike rent each hour of the day, temperature in Celsius, humidity in percentage, wind in percentage, wind speed in meter per second, dew point temperature is mj per meter square, rainfall in snowfall is centimeter, session, winter, summer, autumn, spring, holiday, no holiday. Functional day, there are the two types: the non-functional, which have non-function hour, and function have the functioning hours. There is a no missing value presenting, there is no duplicate value present, there is no null values. And finally we have the rented bike variable, which we need to predict for the new observation. The data set so the hourly rental bikes for 1 year from 1st December 2017 to 30 November 2018. We consider this as a single year data, so we converted the data column into three different column: year, month, day, and year. We change the name of the some features of our convenience, so they can bike rented count, hour, temperature, humidity, wind speed, dew point temperature, solar radiation, rainfall, snowfall, function, day, weekend. There are the two types of graphs. First one is unorganized, and there is a box plot. In the above graph, first one graph shows that the rental bikes count has a moderate right skewness. You can see up and down. Since the observation of the linear regression is that the distribution of the dependent variable has to be normal, so we should perform the sum operation to make it normal. And in the bar plot shows that we have detected the outliers in rented bikes. Analysis of rented bike columns. So we have the plotted the again graph in between the rented bike counts and bike count per hours. So in the first graph we have the generic value of for applying square root for the skewed variable in order to make it normal, and after applying the square root to the skewed rental bike counts. Here we get almost normal distribution. After applying square root to the bike rental count column, we find that there is no outlier present. Analysis of month variable. From the above graph bar plot, we can clearly see that the month 5 to 10, the demand of the rented bike is high as compared to the other months. These months are compared inside the summer sessions. Analysis of weekdays, weekend variables. So from the above point plot and the bar plot, we can say that the weekdays which present in the blue color shows that the demand of the bike higher because of the office. Peak time are between 7 to 9 am and 5 to 7 pm. The orange color represent the weekend days and it shows that the demand of the bike rented are very low, especially in the morning hour. But when the evening started, the 4 p.m. to 8 p.m., the demand slightly increases. Analysis of hour variable. In the above plot shows the use of rented bike according the hour and the data from all over the year. Generally, people use rented bikes during their hour over 7 a.m. to 9 am and 5 p.m. to 7 p.m. Analysis of functioning data variable. In the above bar plot and a point plot which shows the uses of bike rented of the functioning day or not, it is clearly shown that people doesn't use bike rent in no functioning day. Analysis of session variable. In this session variable, we can clearly see that there we have the plotted the graph between the session and numbers of bike counted. So in the summer there are the much demand of the bike session in this particular and the less in the winter. Analysis of season variable. In the above bar plot and a point plot which shows that the use of rented bikes is in 4 different sessions and it clearly shows that in summer the use of rented bike has at peak time is 7 am to 9 am and 7 pm to 5 pm. In winter session the use of rented bike is very low because of snowfall. Analysis of holiday variable. In the above bar plot and point plus which shows the use of bike rented in the holiday and it clearly shows that the plot shows that is holiday people use the bike rent from 2 p.m. to 8 p.m. Numerical and bike rented count. From the above plot we can see that the people like ride bikes when it's pretty hot around 25 degrees Celsius in average. From the above plot or in second one the dew point temperature is almost same as the temperature. There is some similarity presents. We can check it in our next step. The above point we can see that the average the amount of rented bike is used when there is solar radiation. The counter of rent is around 1000. You can see in the third graph, third plot. Regression point plots of numerical values. So here you can see I have plotted the 4 graphs which can shows that the plotted the graph between the rented bike counts and humidity, wind speed, temperature and visibility. According to that the first one, Regression plot of numerical. From the above regression plot of numerical, we can find that the column temperature, wind speed, visibility, dew point temperature, solar radiation are positively related to the target variable. The rented by count increases with the increase of these features. Rainfall, snowfall, humidity, these features are neglected with the target variable mean the rented by count decreases when these features is increases. Regression plot for numerical variables. Here we can see these are the four graphs I have plotted, which can show the which can be compared using by different types of sessions like visibility, temperature, dew point temperature, snowfall. OLS regression model. R and decent square are the near to each other. 40% of variance on the rented by count is explained by this model. Here you can see the regression result. The p-value of dew point temperature visibility are very high and they are not sufficient. Correlation matrix. Variable like dew point temperature and temperature are correlated. Model building. Linear regression, lasso, rigid regression tree, random forest, gradient boosted, gradient boosting with grid search CV. Linear regression, train set result and test set result, discussion tree, train set result. In the train set result, we can clearly see that the mean MSME values. In the discussion tree, we also see that graph according to the train set result and the test set results. Train set result, train set result. These graphs, these values are regarding the lasso regression, rigid and the elastic net regression. In train set result, there are the adjustment R2 is 0.3922 and test set result is 0.379. In rigid regression, train set result is 0.7672 and test set result adjusted R2 is equals to 0.78. Elastic net regression train set result is adjusted R2 0.61791. Test set result 0.61538. Random forest. Here are the some features important for the random forest. Here we can say R2 is equals to 0.9894 and train set result is 0.9171. Here is a graph between features importance. Gradient boosting regression with grid search. In the grid search, the train set result is with adjusted R2 is 0.958 and test set result is 0.9198. Here are the we have used the hyperparameter, and hyperparameter is a model argument whose value is set before the learning process begins. The key to machine learning algorithm is hyperparameter tuning, and here is a graph of hyperparameter tuning with according to the grid search. Challenges in the project, we have the faces large amount of data sets to handle, needed to plot lots of graph to analysis, feature engineering, feature selection, optimizing the model, carefully tuned hyper parameter as it is affected. Conclusion. Hours of the days hold the most important features. Bike rental counts is more correlated with the time of the day at its peak at 10 a.m. morning and 8 p.m. in evening. We observed a bike rental count high during working days than the non-working days. We see the people generally prefer to bike at a model to higher temperature when the little windy. Conclusion: we also compare the root mean square and the mean absolute error of the model random forest regressor, and the gradient boosting grid search give the highest value of R2 score of 99% and 95% train set result, and test set result is 92%. So finally, this model is the best for the predicting the bike rental count on the daily basis. Here you can see the different types of regression model we have the part done in the project. Suppose like linear regression, lasso regression, rigid rejection, elastic net rejection, and tested result you also can see is around 0.78, 0.35, 0.37 according to the project we have concluded. Thank you.